Right.
And then kind of move on with today. So all of these problems are kind of set up the same way. You kind of just have to get in the habit of starting off these problems like this. So for number 9, it talks about the length of a rectangle. When we were talking about the length, we know that this is going to be some equation because it has the word is. And then it says 6 inches more than the width. So that means we are adding. So to set that up, our length is 6 inches more than the width. Remember, in these cases, we don't have to define our variables because we know it's length and width of whatever. Then we know our perimeter is 2 times our length plus 2 times our width. So we can put in everything we know, our length and our perimeter. So 24 equals 2 times, we found this to be our length. And then add that 2w at the end. And then from there we can solve. So this would be 12 plus 2w plus that original 2w, that's your width. Combine your like terms. And then we can solve for w by subtracting 12 on both sides. W and dividing. I switched those, but that's okay. And then make sure you're putting units. So these are inches. Then if the width is 3 inches, what is your length? 9. Any questions on number 9? And then 11 is set up very much the same way, except the length is a little bit more complex. So still talking about the length, we know there's going to be equation, and it says 3 centimeters less than twice its width. So less than, we're subtracting, but that's going to go at the end. Twice, we're going to multiply by 2. So our length is going to be 2w minus 3. And then we can put all of our information into the perimeter formula equation. So 18 equals 2 times our length plus 2 times our w. And solve. So this would be 4w minus 6. Combine our like terms. And now we can solve for w by adding 6 to both sides. And dividing by 6. So we know that our w is 4. I'm going to make sure that I have my units. This is centimeters. Then we have to put that 4 back in for L and figure out what that is. So 8 minus 3, 5 centimeters is our length.
Could it also be 6 and 3 as a combination?
Let's see. We're 6 and 3. 6 being your length, you mean?
Yeah. No, I mean 6 is width.
Yeah,
L is
length.
So already this doesn't make sense because our length has to be 2 times our width minus 3. So that would have to be the other way around.
Remember I did it, I got that as well, it's, I forgot to, like, add another 2 for the activity. I don't know if you got that.
So if those were switched, it's close, but this still isn't, this is 2 times, but not less than 3. I could also put those back in and it wouldn't work. So if I put this back into the original, what you originally had was 3 and 6.
Well, it doesn't matter.
What I have and what they had was different at first. Yes, this part works, but it wouldn't work for the equation. So then that means it wouldn't work for everything. Any other questions on that one? We're going to go back and do number 6. So this one, I had you like try just to see if you could do it. The setup is kind of the same as what we were just doing. It's just not length and width. So for this one, Garrett has $1 less than 3 times as much money as Liz has. Together, they have $179, and we're looking for how much money does only Garrett have. So in this one, you have to define your variables. Here you should have, I would say, start off with 2 variables. You may end up needing both. And I'm going to say G and L. So this would be the amount of money Garrett has. And L would be the amount of money Liz has. So anytime you do a word problem, there should be something you don't know. It might be multiple things you don't know. And you need to define your variables. This first sentence tells us something strictly about Garrett, so we can make an equation for him. $1 less than 3 times as much money Liz has. How would we write this equation? L3 minus 1. I'm going to put 3L minus 1, but yeah. Less than, we're subtracting, the 1 has to go at the end. We're multiplying, it actually says times 3 and L. And then we know that together, if I had, let's say, some other equation, if I had G and I added L, I would get 179. Except I now know that this is what G equals, so I'm going to put that in for G. So this would be the amount Garrett has plus the amount Liz has to together get 179. After we find that part, we can solve it. So combine our like terms. And now we can solve for L. So add 1 and divide by 4. Your units here would be dollars. us what does, or how much money does Liz have, that would be our answer, we'd be done. But we have to go back, put that in, and figure out how much money Garrett has, because that's actually what it asks.
Would it be Garrett's one?
It has to be more than 3 times as much. I'm going to put this over here. 3 times 45 minus 1 equals G. This would be 135. The 134. Once you kind of get the hang of, okay, I have to set up an equation and kind of put that into like another equation. The process isn't that difficult, but you still kind of have to think about it. And it's weird at first. Do you have any questions on that one? So like I said last class, most of the problems you'll see will either be like the perimeter questions, or it'll be like the post office question.
So I don't like this one.
Not really. This is like the perimeter question, but you would see more of the perimeter question. I'm gonna pass out your notes. How I think of solving this, I think of this acronym. Don't call me after midnight. One, I'm not usually awake at midnight anyway. So for this acronym, let's just rewrite. Oh, that's what I did. Okay. The don't for this is distribute. So if you can, or if there's parentheses, distribute. The call in this is combine like terms, but on the same side. So these steps are kind of like what we did before when we were solving, but there's another one. Move the constant or variable. So we'll see here in a second where it says either or, because you'll have some choices you can make. Some of these you won't solve the same way. And you do that by adding or subtracting. And then get the variable by itself by multiplying or dividing. Yes. Move the constant or variable. So we're going to do this one, and then we're going to solve it a couple different ways to show you how this works. So first, for this example, we have parentheses. We can distribute, so we're going to do that first. So distribute the 4. We're also going to distribute this 4. So we're going to do this simultaneously at the same time. 8x plus 4 minus 2x equals 8 plus 4x plus 20. When we solve these, our end goal is to get all of the variables on one side and all the constants on the other. So keep that goal in mind. The call, we're going to see if we have like terms on the same side and combine them. So remember, do whatever it says. So on this side, 8x and negative 2x becomes 6x. And then 8 and 20 would become 28. combine like terms on the same side. Make sure you guys are taking notes and paying attention. From there, we can pick any of these terms to move to the other side. So someone pick one of the terms, 6x, 4, 28, or 4x. Which one do you want to move? Taylor. 4x. 4x. So if we're moving 4x to this side, we need to do the opposite and subtract. Because we moved our constants to the left, or our variables, we moved our variables to the left, we now have to move our constants to the right. So we picked one, we moved it, and now we have to add and subtract the other. So we're going to move our 4 over. And then divide. It's okay if yours doesn't match up exactly the same, as long as you're doing those steps. So somewhere on this page, we're going to rework this problem to be more hands. But we're going to start right here. Just to show you that the other ways work as well. 6x plus 4. Okay. So the very first time we move 4x, let's move something different this time. Caleb. Okay. So if we're moving 4, we have to do the opposite, subtract it to the other side. So now we have all of our constants on the right, which means we have to get all of our variables to the left. So we still end up having to subtract this 4x over. We already know that this is going to equal 12, so we don't have to do that again, but you could. Actually, I'll do that here, but I won't do it for the other two. So we solved this 2 different ways and still got the same answer. Somewhere else on this paper, write it again. So we move 4, we move 4x. We still have 2 others. So we'll do 28. This is a positive 28, so to do the opposite and move it, we have to subtract. So this would be 6x minus 24 equals 4x.
And doesn't matter which
So if it's a constant, we have to subtract it to another constant. If it's a variable, we have to subtract it to another variable. Or add it, whatever. So now that we moved all of our constants to the left, we now have to move our variables to the right. So this is a positive 6x, so we have to subtract it to the right. If I divide negative 24 by negative 2, do I still get positive 12? Yes. And then we're going to do this one last time to show you the last way works as well. And you have to move 6x. Now we're going to move 6x by subtracting. And since we moved our 6x to the right, we now have to move our constants to the left. So we're going to subtract 28. And we end up with that same thing we just got before. So the point of doing that 4 times is to show you that I may solve it differently than you may. You may solve it differently than your partner next to you, someone across the room, because there's 4 different ways that you could be solving this. So once you get to that step, it's okay if you're solving it differently, as long as you're solving it correctly. Moving on to the next page. These are very similar to the first set of notes we did where they solved it for us. We just had to say what they were doing at each step. We're going to do that same thing, except now they're solved on both sides, so we have to look and see what did they do there. This has 4, 2, 3, 4, so we're going to do 2 of them, starting with number 4. So this first part is given. From step 1 to step 2, what did they do there? So I've heard 2 different things. Stella, what did you say?
They moved.
Moved it how?
They subtracted it.
And Peyton, is that what you said? Okay. So they subtracted on both sides. So that would be your subtraction property of equality. And then once they have that variable on the other side, everything else is kind of the same. So from step 2 to step 3, what did they do? They added 4 on both sides. And then from step 3 to step 4, divided. Questions on that? We're going to do number 7. Because that one has a lot of steps. So step 1 was given. From step 1 to step 2, what did they do? Distribute property. From step 2 to step 3,
They added.
so they move this over here.
Yeah.
We don't have another set of parentheses, so they didn't distribute again. They didn't divide. What did they add? Peyton, what did they add?
They added like terms.
So I would just say combine like terms. So 14 minus 16 to get the negative 2. And 5x minus 3x to get 2. So combine like terms. So So combine like terms on, when you do it on the same side, you're using whatever operation it says. But when you're moving things, you have to use the opposite sign. Then from step 3 to step 4, what did they subtract? So they subtracted this 2x to the other side. From step 4 to step 5, added 2 to both sides. And then step 5 to step 6, divided on both sides. In a second, I'm going to give you time to practice these two, but I want to give you one of them. From step 3 to step 4, all they did was switch the order. That's your
Associative?
it's your
Translations?
symmetric property.
Yeah, that is. No, the extra 3 together. Translation.
What are they?
Hold on a second. So that one I'm giving you, that last one is symmetric property. I'm going to let you guys work through 5 and 6, talk with the people around you, compare answers. I'll be walking around if you have questions or want to check yourself, and then we'll come back and take this in about 5 minutes.
No, look. Look.
It's like a smiley.
No, look, no, the bottom.
That hurts. Yeah, Tim. I'm so sorry.
I did this like all of
Yeah, the next.
Yeah, I've done this every single year.
Same.
Right. For number 5, you should have had subtraction, property of equality, division, property of equality, and then I gave you symmetric. Do we have questions on either of those two? So unless you have a question, I shouldn't hear your voice. Number 6 was distributive property, addition property of equality, addition property of equality again, and then division property of equality. Questions on number 6? Now that we know or recognize some of our properties, we're going to move on and actually solve these. Yes. Yes, this one, and you have 3 to 5 minutes. Wow, I did not spell his name right. We're not going to do every single one of these together because I want you guys to try some, but we're going to start at number 2.
Can we do number 4, number 6?
We're going to do number 4. We can do 6.
I just hate fractions.
And
The first thing that I actually failed in was fractions.
for number 2, what would be our first step? We need to get all the variables on one side.
Number 2.
Subtract 3w. And then
Divide.
what would w equal? Yeah, so for these you can put fractions or decimals as the final answer, unless it says leave it as a fraction or put it as a decimal. I would still put these back in, make sure they work. I'm gonna do that really fast. If you put this in your calculator, these should equal 3 times 0.5 or 3 divided by 2. Add it to 2, you would get 7/2. A little later, I'll show you how to do these. Check yourself in the calculator or in Desmos after we solve some of these. For number 4, you have a fraction that equals another fraction. Anytime you have fractions that equal each other, you are going to cross multiply, so that means take this, multiply it to this, and vice versa. And we're going to rewrite it, yeah. So cross multiply. So this would be 3 times 9x minus 3 equals 9 times 5x minus, or plus 5. Whether you write this over here or this over here does not matter, as long as there's an equal sign in between them. Once it's in this format, the solving part is the same as what we've been doing. Distribute. We don't have like terms we can combine on the same side, so we can pick something to move. What do we want to move? Hands. Okay.
Plus 9.
Okay. So move 9 by adding it. And because we moved 9 over to the right, we have to subtract 45 to the left. Someone tell me what that is. 27 minus 45. Okay. I was going to say, I don't think it was 50 27. Okay. And then divide both sides by negative 18. What is x? Negative 3. So don't let problems like 4, 6, I think there's another one, 7, don't let those confuse you. Just cross multiply, rewrite it, and then the problem is the same.
Question.
Yes. No.
If like, for example, if the denominator was in the numerator, will it be the same thing?
I'm not sure I understand your question. Give me an example.
Like, number 7.
You can say that question.
So you mean if the variable is in the denominator? Yes, as long as you have a fraction equal another fraction, you cross multiply. Okay, look.
Maybe scroll back up to number 2.
To number 2.
Okay.
Or what number?
Thank you.
Yes.
Can you
Say that one more time.
scroll down a little?
Hold on, 1 second. Michaela, do 22.
No, thank you.
We're gonna do number 5. For number 5, what would be our first step? Kayla. Yes. On both sides. When we distribute this fraction, think about that like when we were simplifying and had to distribute the fraction. Divide instead of multiplying. You could also multiply, but it'd be easier to think about this as 24 divided by 3, 12 divided by 3. Because most of the time, not all the time, but most of the time when you multiply these by fractions, they simplify to whole numbers. Not always the case. There'll be some examples where you end up with fractions in your problem. Okay. Pick one of these things to move. Kayla.
18.
8m. So we would subtract 8m. If that's not the one you wanted, you can move something else. That's fine. Remember, we don't call each other dumb.
That's a bad word.
So that would give us 22m minus 18 equals 4.
Wait, that equals 22.
Yeah, no, we're going to say, did I do math wrong? That happens, but
See, I'm a little slow at times, so.
no, you're fine. Okay, then solve for m, add 18 to both sides.
You're right, so no, but it's like.
And then divide both sides by 22. Correct.
How? It's your quick right.
22 divided by 22.
Oh wait.
18 plus 4 is 22. It's okay.
Haha.
No, you're not done. You can't call other people dumb and you can't call yourself dumb. No. See, it's the rules.
I don't care about the rules.
Why can't I call myself
the rules?
It is the rules somewhere over there. And there.
I'm gonna say it in my head then.
It's okay to not know, but it's okay, not okay to not
That's
try.
not what
It's okay, all to know.
What's my teacher's just care if I'm in class and try to get it? It's okay to not know, but it's not okay to not try.
Yeah, you can say
I'll try.
but that's also not what I was talking about.
Oh, that is a cool word.
Yeah.
Right there. The purple paper.
Oh, cannot, foul language, stupid stuff, don't know.
He said,
I don't know. Can I say I don't know?
I don't know.
You say, I don't know.
I don't know what to do.
You can say, I don't know what to do yet.
Yeah.
Yes.
Oh my god.
Oh, I said I don't know.
I don't know what to do.
Yeah.
Future.
Yes. Do you have any questions so far?
Yes.
We're gonna go back and, or we're gonna do number 6 now.
Yay, let's do number 6. because that's confusing.
We have two fractions that are equal to each other. How do we want to solve this?
Can you verify the 8 in those parentheses times and
So to get this, what did we have to do?
Cross multiply.
Cross multiply. You need to keep those words in your brain. CK, what words do you need to keep in your brain?
We're doing number 6, right?
What words are you supposed to keep in your brain?
What do you mean words?
Don't wake me up at night.
What?
Call me at midnight.
You said don't call me at midnight. You had
Crosswords. Multiply.
multiply by.
Cross multiply. That's not what I said.
Here's the there.
Hold on 1 second. Say that one more time. Say that one more time. Hayden, you're confusing him. Say that one more time.
I thought that it was still don't call me at midnight.
Don't call me at midnight is to solve this. When we have two fractions that are equal to each other, what are we supposed to do?
Cross multiply.
Cross multiply. The words you need to keep in your brain.
We didn't have any simplify?
And you can multiply diagonally. Cross multiply. Okay, so distribute, and then we don't have like terms on the same side. We can combine. What do we want to move? Hayden?
16. Wait, no, 64.
But like some of you are working ahead. That's fine.
Wait, so I did 8 plus 8, not 8 times 8.
Yeah, that is another big problem. Make sure you multiply.
See, I'm a little confused at times. So, see, it's not on the board. So, I mean, on the list. So, I can
But
say.
you knew what you were doing, so you're not doing this.
And you guys are idiots and have one or something.
I'm 8 years old. I don't know.
So n should equal 6.
Wait, what? 6. Yeah.
Why don't you divide?
So anytime we have variables on the same side, we cannot divide. I'm saying this because some of you are going to do this by accident. We should be adding or subtracting to get variables on the same side. And then if you have a variable in front of, or I'm sorry, a number in front of the variable, when you're still solving, that's the only time you can divide or multiply. If needed.
Because it's 1 and n is 1.
So this is really 1 n, so I wouldn't need to divide anything. But I can't divide this by 7 because I'd have to divide everything by 7. I can't divide this by 8 because I'd have to divide everything by 8. And even though the fractions deal with that.
I hate fractions. Why do fractions have to exist? Literally.
Yeah, that's
Think it's still part of math.
So there'd be a lot of numbers missing if there weren't. Okay, so there are, how many others? Number 1, number 3, 7, 8, and 9. I want you to go through and I want you to try for the remainder of class. When you finish those problems, do not go get your phone until I say so, please. Work on those. If you have questions, I'll be around. You can ask me to check them or go through one with you, or if you have questions. So, really quickly, I'm going to go through the answers. If you have questions, questions, ask. And please don't leave in your chair. Thank you. For number 1, you should have got -4. All the different colors are me solving it different ways. So find the way you solved it. As long as you got -4, I'm sure you solved it wrong. For oh yeah, I don't think I picked anyone's for number 3. But for number 3, you should have got -1.4. For number 7, either the fraction 23/5 or the decimal 4.6.
I got -8.
Number 8 was -5.
No, we went over 5.
No, for number 5, the one in the fraction, yeah, we did. Number 9 was. It should be 4. I have to look back at that. I don't know why that said 32. It should be 4. But it's over there. Yeah, look at the red one, not the blue one, because. Do we have questions on any of those? -5. Before you guys pack up, because I really don't want to talk over all your papers, wrestling, pause for 1 second. You don't put anything else away and pause. You will have time, I promise. Okay. We're going to continue these notes and start our other notes next time I see you. However, Monday, we don't have school because of touch base. And happy early birthday. Which means Tuesday is now a gray day. Wednesday is a blue day, but Wednesday is a PSAT, so I will not see you at all. You got 4th and 6th, but it'll be later in the day. I think 6th is only like 32 minutes. So I will not see you again until Friday. Okay? You have 2 Khan Academies that are due on Friday on this. Part of that, we have to finish these notes on, so you are more than welcome to try them before then. You are also more than welcome to come before or after school to go over those with me any day that we're here next week. Morning or afternoon. If you have not taken your test or need to finish your test, make sure you come get that done Tuesday as soon as possible. If you did not do the Delta math or try the Delta math of the first part, try that. Also try the second part, so the multi-step equation and the solving multi-step equations with variables on sides. You have 1 Khan Academy due this Friday on the word problem stuff from the last 7 notes year. Does anyone have any questions on all of the things you should be working on until the next time I see you next Friday? Owen.
So like we are allowed it's like we need to compare.
Say that one more time.
So like say we need to take a test and we compare during the week on Wednesday.
Yes. You can come here Wednesday, Tuesday, Wednesday, or Thursday afternoon, any of those mornings. Actually, probably not Wednesday morning. Wednesday afternoon is fine, not Wednesday morning. Alright. You guys can get over to your topic.